Thank you. Good to see everybody.
Thank you, everyone. We are between you and closing Cisco Live. So, I'm Murali Gandluru, and what we're going to talk about is something that you've heard as a theme throughout the show. First and foremost, as you know, there's big shifts happening in the data center. You've seen all the announcements. Obviously, it's been predicated by the fact that enterprises are dealing with a lot of complexity in managing their networks. They're dealing with AI infrastructure and management of those infrastructures. That's also new. So how do we help organizations that are facing those complexities deal with that while managing also security concerns? That's basically the premise of this presentation. And so if you think about it, you've seen a whole bunch of hype cycles, and obviously this time last year, we were talking about LLMs. We were talking about how LLMs are going to change the way we work, the way we play, all of those things. This year, it's about agentic agents, agentic webs, all of those elements. And going forward, we're talking about physical AI. So in all of this, enterprises are just trying to figure out, what does it mean for my network? What does it mean for my infrastructure? How do I future-proof that investment? That's primarily some of the elements that we'll be talking about. So when you think about a network that enterprises have to manage, enterprises look at this as parallel GPU workloads that create unpredictable, bursty traffic. They create a need for things that are more than the traditional load balancing techniques for avoiding congestion, but also for utilizing the fabric to its maximum. And so one of the things also that implies is that AI jobs require lossless and predictable packet delivery. So combining all of these, to do that, you will have to also, but on top of that, you have to also factor the point that not everybody is deploying back-end environments, which are primarily GPU load based, but also front-end, which has a mix of CPU and GPU environments. So in such an environment, do we have answers out there? Cisco definitely is ready for both of these worlds. And the answer is not more tools or more different management paradigms and operating models. It's actually the fact that Cisco has always, in every environment, focused on providing a single converged operating model and the management plane for these environments. So front end, back end, storage, management, all kinds of networks. And so whether you are modernizing your traditional workloads, whether you're building out new backend environments, whether you're moving from InfiniBand to Ethernet environments, Cisco's approach has always been about unification, scalability, and providing security at scale. For that, we have to start from the foundational blocks. And one of the things that we've talked about again and again, both at Jeetu's keynote and the various deep dives that we had, is that we start from 4 key principles, right? Differentiated silicon, build systems on top of that differentiated silicon, optics, our own optics as well, software, and the operating model. So these 4 elements together help us build out this foundation that you see out here. You see the Cisco networking portfolio built out of Cisco Silicon One and Cloud Scale ASICs. The range goes all the way, especially for AI workloads, 400 gig, 800 gig, and onwards. We have liquid-cooled switches that we showed at the World of Solutions. It was so exciting. I've not seen such a crowd for a long time. And those are Nexus switches, 64-port, 800 gig switches out there. So innovations across the board built in-house. Bi-die optics. Bi-die optics is something that's really close to my heart because, well, this was invented at Cisco. And when you think about it, we are able to provide a lot of savings to your environments, operational environments, by reusing them as you go from one generation to the next. So here we are talking about 400 gig bi-die. In addition to that, we have 800 gig QSFP, OSFP-DD optics for AI environments. Then, of course, you marry that with the compute and cloud-based delivery that we have with Nexus Hyperfabric that you'll touch upon a bit more as well. So all of this are the key elements of the foundational block for enterprise workloads for AI. So when you think about that, ultimately when you have all those foundational principles and blocks, and then when you look at what does it take to actually power those networks. So it includes some amount of innovation in the data plane. It involves some amount of sustainability innovation that I just referred to. Then you have to be able to monitor those environments. And finally, you want to be able to take the data that is built out of that network. It's a wide network, multitude of networks, and then stream them out into a data lake, get insights that you can actually do much more richer outcomes with, because they also go cross-domain. So these are things that has been the theme of Cisco Live. In many ways, this session is sort of recapping all of the announcements, at least as far as data center networking is concerned, and bringing them all together and highlighting what they mean for us. Right? And I'll just quickly go over a few things, Jake, if you don't mind. Well, one of them is around intelligent packet flow. Right? Intelligent packet flow is a bucket of capabilities that is built out of Cisco Silicon One differentiations, and essentially basic ECMP doesn't work, is not enough anymore, right? You want to be able to do things when you have especially a mix of CPU and GPU workloads. You want to be able to do things like flowlet load balancing for the traditional workloads, as well as be able to do packet spraying for job latency sensitive GPU workload to workload communications. So can you do that simultaneously? Can your network be flow aware? Can we actually send telemetry data out to highlight the latency and job completion times and other kinds of errors that may occur? Those are things that our silicon brings out. Then there is all of the elements of optics that we can also bring together with that as well. So intelligent packet flow is a technique or a bucket of capabilities that we are bringing to market with our AI fabrics. Of course, as I was just saying, we have to monitor these things, right? We have to monitor this, and where else other than the Unified Nexus dashboard. Unified Nexus dashboard essentially now allows you for AI jobs to take a global site level view. Once you've looked at the site level view of all kinds of networks that you're managing, go to the backend view, backend network that you are specifically zooming into, and then look at the jobs that are there in those backend networks, and within that, see what kind of anomalies exist, what kind of healthy or unhealthy optics exist across a fabric, what kind of cable and mismatches exist, things like that. And once we look at it, and then we go and then zoom into a particular job that we want to double click or triple click into, what you get to see immediately is actually you're able to go down to the point where you see, okay, it's this particular GPU that is sending a flow out or probes out across a particular link that we are seeing degradation. Then you can actually go further in and see that, okay, that degradation is actually caused by a temperature exceed threshold issue. So you're able to go from a macro level, a zoomed out view, all the way down to a particular job, a particular anomaly, get more information about it, and then take action. This is unprecedented because it also applies across both front end, back end, all kinds of environments. And again, this has been built on the foundational principles of the Unified Nexus dashboard. This Nexus dashboard now allows you to manage not just Nexus OS fabrics, but also ACI fabrics, and also the plug-in expansion into third-party and storage area networking environments as well. So it's the complete package. And you get to see services like AI, see services like Data Broker, services like Insights, and then, of course, streaming this information out into Splunk Cloud through connectors, or through the embedded approach as well. So apply all of the AI elements to this, and you get a complete solution. So what I wanted to then highlight is that this is one approach, approach to how people deploy fabrics. So Jake, one of the things that we've talked about also is a cloud-delivered model that is much simpler and easy to design, build, and run. So do you mind taking us through that, Jake?
Yeah, absolutely. Thanks, Murali. So hi everyone, my name is Jake Katz. I'm going to step you through Cisco Nexus Hyperfabric AI. Now, just to set the playing field, what Murali just talked about, Nexus Dashboard Fabric, private cloud manage, is something that you guys are probably very familiar with, very flexible, right? So cloud scale, Silicon One, operates with all kinds of partners. What I'm going to talk with you about is a different operational model of deploying AI clusters. Hyperfabric AI is specifically I'll call it a pre-designed cluster for you. Obviously, you design what you want in the cluster, managed through the cloud. So the operational model is cloud managed, on-prem AI switching, AI GPUs, and storage. It'll take you through starting with design, then build. So design order, build, it lands, validation, then operation, then adds, deletes, the entire life cycle of the data center for that AI cluster. So let's get a little bit more into that. It is built off the basis of Cisco Nexus Hyperfabric. Hyperfabric is actually available today. Hyperfabric is just the switching element on-prem that is managed via the cloud. It does the same thing that I just mentioned. It starts with design, build, validate, run, total operational life cycle for that switching element. What we've done is we've taken that and moved it one step forward. And what does that look like? So here at the top, what you see are the switches. So pods of plug-and-play leaf spine switches. These are very high performant, 400 gig, 800 gig, eventually 1.6T Ethernet. So this is all based off of Ethernet. So high performance Ethernet, cloud managed. If I stopped right there, that is Hyperfabric. That's available today. That's orderable, shipping today. What I've done is I've taken that and brought it down one more level to now the UCS servers. So this UCS design here is basically an HGX device, 8 GPUs, H200 class, with NVIDIA BlueField 3 NICs for east-west, and a BlueField 3 DPU-enabled NIC for north-south. We also have the option for in-cluster storage, supported on a UCS device, but it's through VAST storage. So we have the entire cluster. So you have networking, you have compute, your GPU-based compute, and you have your storage all in one cluster that is managed via the cloud. And it will take you through that entire life cycle, that design, build, validate, operate life cycle. I'm going to get to that as well in just a second. I think I have time. Also, I want to point out, I'm really talking about hardware stack here, but we also support the entire NVIDIA NVAIE stack. So NVAIE, NVIDIA AI for Enterprise, along with their NIM containers, are fully supported here. Okay, a quick step through. So we're logging in. Actually, you could log into Hyperfabric today if you wanted to, without the AI portion. If you have a Cisco login, you could go in and log in and play with the tool. I'm going to show you the AI extension.
And
so
what's the URL for that? It's hyperfabric.cisco.com?
I believe it is. You asked me a hard question there, because I actually just have it auto-populate. So what would I do? The first step I do, and what I'm showing you on the left are actually fabrics you could build today with Hyperfabric. And then you would just go to the AI extension, because that's what I want to build. So I go through that. The first thing you would do is decide on the number of GPUs you want. The count of GPUs is going to be the basis for everything we build. It's going to decide the back-end network. If you decide on storage, it's going to decide on the storage network. The whole thing is going to be configured from that. And we're going to do it based on the count. So it might be kind of hard to see, but we're actually starting from small to medium to large. These are just delineations for counts of GPUs on how we build out the network fabric, okay? And so you'll see, if I break it down, you'll start at the top, back-end switches, management leaves, storage leaves, GPU servers, storage servers. You would go in and configure all of these through the management tool day one. This is how you would build your design, okay? For this demonstration, we're just going to select medium AI cluster, which is up to 96 GPUs. So you do it based on GPU count. It would then explode each of those boxes that we saw there. So at the top, you see back-end leaves. You would go in and configure all of your back-end leaves. The tool will actually help you. It'll go down all the way to the optics count and the type of optics. If you wanted to actually do cable planning, it would actually lay out the cables as well. We're trying to put everything together to make it as easy as possible. I don't want to say the easy button for AI, because I don't think there is such a thing for landing AI clusters today. It's just not, it's not reasonable to say that. But what we're trying to do is give you access to the quickest time to value. because you're landing really valuable assets. Those GPU servers are worth a lot of money. You don't want them sitting for 3 to 4 months not being operational. That's the whole key behind Hyperfabric AI. So you'd go through, you'd configure each of these, you can double click down, go into optics. You can actually even assign rail groups. If you're familiar with the concept of rail groups, it's basically GPU to GPU affinity, and then you actually wire that into the leaf switches. So you could do that. We allow you to do that. You would go through and do that for starting at the back-end leaves, then you would configure management leaves, storage leaves, GPU servers, and so on. What is this going to do at the end of the day? It's actually going to spit out a BOM that you could then order, right? So you would order it, and then, of course, the nice Cisco packaging, it would show up.
It gets rid of all the spreadsheet back-end work that typically operators
If you want to do that, you are welcome to do the spreadsheet, but that's actually what we're trying to get away from. We're trying to actually put that into the tool. And like I said, it's not going to make you count those number of optics, number of cables. It's going to do that for you.
Nice.
It's actually going to map out the cable connectivity, the topology. So for instance, if you wanted leaf spine topology, which is pretty familiar to all this, that's pretty simple, it would lay that out. If you wanted a rail-based design, the connectivity is different. And what it's going to do, it's going to get shipped to you. Cisco professional services or partner professional services will help you bring this up. And then once these switches plug in, once they have network connectivity, they validate to cloud. They authenticate into the cloud-based management device, so do the UCS servers, saying they are part of this group. And then they will validate versus the BOM that you configured. So if you miswire, the management tool is going to tell you that you've not configured this to the design that you put into the tool.
Got it.
It's a pretty powerful design. I want to spend just a minute on our relationship with NVIDIA.
Yes.
Because it spans both of our products. So about a year and a half ago, Cisco Live EMEA in Amsterdam a year and a half ago, we announced our partnership with NVIDIA. It was originally around Hyperfabric AI. And it was us to do the kind of things we're doing, putting management agents on the NVIDIA HGX style servers as well as the Bluefield 3 NICs, because we control those through the management controller in the cloud. That has evolved. And so at GTC this year, we announced a Cisco enterprise reference architecture that was validated by NVIDIA.
Yes.
And we have 2 of those. We have one based off of Hyperfabric AI, and we have one based off of Cisco Nexus. So you have your options in how you build this. It follows the very similar small, medium, large configs. Those are based off of NVIDIA reference architectures that we have done and validated ourselves. So that's a Cisco reference architecture for enterprise that we have created ourselves. So what does that mean? From componentry level now, Cisco networking, right? So you have your choice of Cisco networking, whether it's Hyperfabric AI, whether it's Cisco Nexus. You have Cisco Compute. You can use the dedicated compute service that I use for Hyperfabric AI or any of the other ones.
Or you could bring UCS and the combos there.
Absolutely. So you have that. Partner storage. For me and Hyperfabric AI, I'm building today solely with VAST. You could bring partner storage into the cluster. It would go through a north-south interface as opposed to an in-cluster storage leaf.
And we have great partners across the board, right? Both
We do.
VAST, Veka, DDN, and then NetApp, Pure. We have a number of them.
We do.
IBM, yeah. So
Exactly.
Absolutely.
So, and then the NVIDIA software stack runs across all of this. So you have the option to run NVIDIA AIE tools across all of this, or your own tools, or if you wanted open source Hugging Face-based tools. So you have all of that in flexibility between Nexus, Hyperfabric AI, UCS, and our storage partners. So just in terms of what Murali and I have talked about, 2 different operational models. One private cloud, on-prem, one cloud-based public cloud. One pretty much bespoke. I'm going to create that cluster for you. You can add, delete, change to it, but I'm really going to dictate like back-end network. I'm going to dictate the storage in it. I'm going to dictate the UCS server. One much more flexible,
Yep.
right? Where you can pick whatever type of server, whether it's GPU-based or not, right? And connect it in through Nexus. We both leverage our own Cisco ASICs, which is pretty nice, and then our own Cisco optics.
Absolutely.
So that gives you everything from front end, back end, storage network.
Absolutely.
Pretty nice. Okay, on to something I think really exciting. We have a customer and a partner here with us today. Please welcome to the stage Michael Israel. Michael is the Chief Information Technology Officer for the Kraft Group and the New England Patriots. And we're just going to do a quick Q&A with Michael. Thanks, Michael.
Michael, how has Cisco Live been?
Awesome. Awesome. I'm ready to go home. You?
We all are. No. So, Michael, I think there's been a lot of announcements around the data centers, and particularly around data center networking. So, from your perspective, how has data center modernization supported the scale and speed of NFL operations, especially especially during game time, but also post and pre-game as well, from your perspective?
From
infrastructure.
From an NFL perspective, anything that's happening on the field is actually controlled by the league itself. Same thing with Major League Soccer. But everything we broadcast in the stadium, our network controls. So our IPFM network is running point on that. We are having to deliver product at higher definition, faster, more efficiently throughout. And it's expanded beyond just what you see on scoreboards. In-suite experience, IPTV throughout the stadium. I have over 3,000 TVs throughout the stadium that we have to distribute content to.
Wow. And so in that context, what role is AI playing? Particularly, I believe that when we think of a particular game time experience, we're thinking about the stadium. But you probably have factories and other kinds of environment. What role is AI playing in your complete end-to-end operations side?
So outside of Gillette Stadium, the Patriots and the Revolution, which is our soccer team, the Kraft Group also operates paper-based businesses. I have a recycling plant in Connecticut. I have 10 cardboard box manufacturing plants along the Northeast, and a commodities business that moves products all over the world, actually. My networking team, some of who are represented here in the audience, they're trying to keep pace with what we are doing from a business perspective right now. We are evaluating where is AI impacting us? Where can we take decisions out of the hands of humans and look to basically make our operations more efficient? And it could be something as simple as transcription services, where I have 3 people that all they do currently is transcribe press conferences. Bringing AI in, we essentially eliminate the need to do that, and we're bringing forward processes in which we can automate a lot of these pieces. The ticketing, purchasing. If you're looking to buy tickets, do you really have to speak to a human to do that? Can you go through a bot to do those pieces and pick which seats you want? In the manufacturing side, if I have 400 orders in a queue, what sequencing should we do to make sure that that paper, it's a roll of paper, is used to the best so that we don't have waste? So we're really sitting with all of our stakeholders, evaluating how they do business across our enterprise, and my networking team is having to keep pace with everything that we're doing. So it's a rather interesting time right now.
Amazing, amazing.
Cool, I get to ask a question.
Yeah.
So, prior to the show, we did a couple of talks with Michael, and I found out some very interesting things. And I was wondering if you could share some of the things that we had talked about before, like you were talking about how you do things in security, in waste management, in tracking of food orders, of objects left behind in the stadium, all these use cases that are very fascinating that you're doing today.
Now, one of the most interesting things we found is that most organizations have security cameras. We have over 550 cameras in our stadium, and that's dormant data that just expires after a certain period of time and gets deleted. We are intercepting that data with an AI tool to look at video anomaly detection, to look at what's happening in our situation. If somebody leaves a bag behind, we can immediately detect that, bring it up to our operations control room, and detect where that person, what was their journey, what cameras did they pass, lead it back to their car and say, oh, he or she wasn't alone, he had 3 other people with him, and look, they all have bags. That's never happened, thank God, but it can happen. We also do things like monitor a garbage can. If a garbage can is overflowing, it will detect that and create a ticket in our custodial system and dispatch someone to empty that garbage can. After 500 visits to a restroom, we can track how many people are going to a restroom and do the same thing, detect and then create an action based on it. We do the same thing in our manufacturing facilities. We can detect the type of raw materials coming off of a truck and provide guidance to our forklift operators put that in the warehouse, put that on a conveyor belt. We can track how trucks are being loaded. Rolls of paper weigh in excess of 3,000 pounds. If they're loaded incorrectly, a trailer can tip. So if we can detect a trailer being loaded improperly, we can create an action into our ERP system and prevent the truck from leaving. So all of these pieces are meant to make us work better, make us work efficiently, but more important, increase your satisfaction without even realizing what's happening at the stadium.
And you're doing at scale,
Yeah.
like for one of these events, not just people in the park, but outside the park. Like, what, can you share with us, like, what kind of scale, like, what kind of population of people the cameras and sensors are?
We have a large concert will have in excess of 60,000 people in the stadium, and we're pinpointing down if there's a fight that breaks out, if a pipe bursts, any type of, I describe it best as like we all grew up with Sesame Street. What in this picture doesn't belong? That's essentially what these types of systems are doing. You're training the model to say, I'm looking for this, and if anything else enters that, you do it. And this is all with data that's just dormant right now. We're just reusing straight security camera footage. Doesn't matter if it's it doesn't matter what the manufacturer of the camera is. We're just looking at that data coming in.
And that's not just in the stadium, that's outside the stadium.
It's outside the stadium as well.
So you could have a few 10,000 people even outside the stadium.
Well, yeah, we learned that the hard way last year with a large concert. I was on my radio, and someone said, well, we have 62,000 unique clients on our Wi-Fi. I said, well, there's only 52,000 people here. How can that be? There was a TikTok challenge going on in the parking lot with 10,000 kids that jumped on our Wi-Fi network.
It's amazing. It's amazing.
Yeah, no, that's funny. So in terms of operations team's perspective, one of the things that we discussed a while back was you're dealing with architectural changes, you're dealing with all of these at the same time. What would you tell a CIO who has to buy into a modernization project as these evolving architectures constantly create new challenges? What would you tell them about why and when, in what scenario would you go for a modernization project, especially maybe around the network?
Well, if you're thinking about a stadium, we span up when we have 60,000 people or 30,000 people. We're used to those pieces, but you're not necessarily used to that in your corporate environment. And our corporate environment sits adjacent to the stadium. So if you're bringing AI workloads in, all of a sudden you're getting spikes. All of a sudden you're getting items that are happening that you're not used to. So my team, my team is having to look at our corporate network and say, what's happening here? Why are we starting to see changes? But the other big challenge that we have, and we've talked about data governance over the years and all these pieces, if someone has the ability to search for something, they're going to find it. And is that what they're finding going up to the public cloud? Right. So we're doing a variety of things right now to make sure, one, we don't constrict what's going on, and give people the tools that they're asking for, but make sure that everything that we have is buttoned up so that people aren't getting access to data that's being shared externally that shouldn't be. So it's a very big piece of what we're doing right now. It's one thing to move forward with AI, but we're doing it with risk in mind and with a security conscience mind as well.
That's amazing. We are really honored to have New England Patriots as a Nexus and a Cisco customer, and across multiple paradigms. You mentioned IPFM, the media fabric, but also to Nexus architectures as well for AI and other environments. So thank you for taking the time, and I hope you had a great Cisco Live.
Yeah, thanks for having me.
We certainly had a great time. Thank you everybody in the audience.
Thanks,
really
everyone.
appreciate you having me ahead. Thank you.